Alright, so Wednesday, we went over how to solve a polynomial equation by factoring. Today we're going to talk about two other methods of solving polynomial equations by factoring. So it's all under the umbrella of solving equations by factoring. Recall what we did on Wednesday. In fact, we're going to start this problem the same way that we started the problem on Wednesday. So what's the first step in solving a polynomial equation by factoring? This is what we did on Wednesday. So unless you were absent Wednesday, everybody should have this in their notes. And even if you were absent Wednesday, that lesson is available to you on Blackboard. So it should make its way into your notes. Matt, what you got for me? What's the first step in solving this equation? Before we find A, B, and C. Go ahead. Set the equation equal to 0. So what do we have to do here? Good. We're going to subtract 6x to the third power from both sides. Okay, notice where I'm putting the 6x to the third power on the left side of the equation. My equation has to be in what form? Standard form. So I know that my 3 is going to go in between the 4 and the 2. So I'm just going to go ahead and put it there. So when I rewrite it, I can see clearly where to put the 6. Okay, good. That's step number 1. Josue, you have a question?
We didn't go over this specific question, right? But we went over this type of.
That's correct.
Oh, okay.
This is a new
Yeah,
problem.
just kind of like
It's a new problem with a different way to solve it. But we start off the same way.
This is for solving a
Alright, cool, man.
by factoring.
This is part of solving polynomial equations by factoring.
Okay.
Yes.
Well, I just wanted to put it all in
Yes.
the same categories.
Okay. Tiara, do you know the next step? No? You have notes? No, before that. You guys are big on A, B, and C. A great alphabetic class. Gerard. Factor. Notice I said factor, not factor yet. Okay.
Gosh, shut up.
Thank you. I want to factor. Now, Gerard said factor the x. He's kind of sort of right. What do I want to factor? What am I looking for? Greatest common factors. So here I've got numbers and letters. So, very good. I can factor out the 3. How did you know to factor out the 3, Yanka? Hold on. Excuse me. It's very inconsiderate for you all to be talking while she's explaining what's going on. Yes, you. Okay. Again. Okay, notice 3, 6, and 12 are all divisible by 3. So I can factor out 3. John said factor out the x. He's correct, but he's incomplete.
X cubed squared.
Which one?
X squared.
X squared. Rod? Others? Notice how this is not just x, but notice how they all have x squared in common. So you have to look, remember, what are you looking for? You're looking for the largest number they all have in common. So they all have x squared. So we're going to factor out x squared. So what do we get? We're going to divide. So 3 divided by 3 is 1. X fourth divided by x2. What is x to the fourth divided by x squared?
X to the second.
you are dividing, look what we can do. Anytime I have x divided by x, what's anything divided by itself?
Zero.
Now, 1. So anytime I have x divided by itself, I can cancel it out. So I have two such instances. So what am I left with? I'm left with x times x, which is x squared. So what did I do here? I actually subtracted. I know it looks like I might have divided. But if I change this to 5 and 3, if I change this to x to the 5th and x to the 3rd, then I can't just divide. If I have an extra x here and an extra x here, what happens? I cancel them out. I still get x squared. So remember, when you divide exponents, you actually subtract the exponents. When I multiply exponents, what am I actually doing to the exponents?
Adding.
I'm adding them. Keep that in mind. I would not be surprised to see a question about that on the verdict exam. Alright, so 6x to the 3rd divided by 3x squared gives me 2x. 12x squared divided by 3x squared gives me 4. Okay, so first step, set the equation equal to 0. Second step, greatest common factor. Okay, now I've got one of my solutions.
0.
0. Remember, this factor out by itself, this x out by itself, one of your solutions is 0. Do yourselves a favor. Do that. Write it underneath. Circle it. Make it clear that you know one of the solutions is 0. Because when we get to the end of this problem and you see the rest of the solutions, if you haven't written down that x is equal to 0, I guarantee you you're going to forget. Because once we factor this 3x squared out of the problem, it's gone. We don't think about it again. So remember, partial credit. Even if you screw up the rest of the problem and you don't get it right, you get 1/3 credit because you got one of the 3 solutions. Okay? Do yourselves a favor. Get it out of the way. Alright, now, next step is to what?
Simplify.
By?
Finding the GCF.
We already did that.
Multiply 8.
Well, generally speaking, what are you trying to do, Nikki?
Multiply 8 times the
Generally speaking, what are you trying to do?
factor add.
Factor. Next step is to factor. So, take a peek. My A value is 1. I should be able to do the factors of C that add up to B. What's the problem?
There aren't any.
Doesn't work. There are no factors of 4 that add up to -2. What are the factors of 4? 1 and 4, 2 and 2. Can't make them add up to -2. So, we learned this back in chapter 4. When we can't factor this simply, what's our factor process of last resort?
Use the quadratic.
Thank you, Jillian. The quadratic formula. Yes, we have to use the quadratic formula. Should have a clue. Should have been the fact that I wrote the quadratic formula up on the board.
I saw this.
So, how do we start out? Identify A, B, and C. A is 1, B is 2, -2, and C is 4. Now the next step is to plug it in, Opposite of B, so -2, opposite of -2 is +2, plus or minus. -2 squared is 4, minus 4 times A times C, all divided by 2A, which is 2. And then we're going to simplify, plus or minus. 4 times 4, of course, is 8. Right?
This. Like the
4 times 4? How about 16? 4 minus 16 gives me, oh, you're not doing anything now, are you? Gives us negative 12 divided by 2. Okay, let's stop right here. Before we go any further, what should you now be thinking about your solution?
Oh, that you can cancel out.
Before that.
Oh. It's divisible by 2.
Before that. What do you notice about this number? It's,
Not a perfect square.
and it's also what kind of number? It's a negative number. When we have a negative square root, we know our answer is going to have the value I. So now we have to go about simplifying the square root of negative 12. So the first thing we're going to do, is we're going to separate that negative 12 into the square root of negative 1 times the square root of positive 12. Because we know that I is in our answer. There may be no I in team, but there is an I in this answer. Okay, now we go to the flow chart. What's the first question on the flow chart?
Is it a perfect square?
No, that's the second question.
Is there divisibilities?
The fancy math term for that is it factorable? Can you factor 12?
Yes.
The answer, of course, is yes, if for no other reason than it's an even number, and all even numbers are divisible by 2. So we know we can factor it. Then we ask ourselves the second question, which was what, Nikki?
Is it a perfect square?
Are there perfect square factors? Exactly.
Yes.
Are there perfect square factors of 12?
Yes.
And what are they?
3 and 4.
3 and, well, the 4 part. So I break my square root of 12 into the square root of 4 times the square root of 3. I know that the square root of 4 is 2. I bring down my square root of negative 1, which I've rewritten as I. And there's my answer. 2I times the square root of 3.
So this would be if it's not, if like the answer like isn't a perfect square?
Right.
Okay. Because otherwise you could just simplify it more and then that would have been the answer.
Right.
So then the 2I.
If that had been 16, then the answer would just be 4I.
Oh.
Because if this is a perfect square, then your factor is simply what's the square root of that number. So if that were negative 16, my answer would be 4I. Since it's 12, we can still we can still simplify it. We're just not going to have a perfect square as our answer. All right, so we go back to our problem. And now we're just going to rewrite our answer. But instead of writing the square root of negative 12, we're going to rewrite it as 2I times the square root of 3 divided by 2. Juan, are we done? Can I go on to the next problem?
No.
Why not? Why not? Okay. All right, anybody at Juan's table? Juan is correct. Can any of you back him up and explain why he's correct? Come on, no one's got your back. Some table. Good job, table mates. Okay, Jillian?
You cancel out your 2's because one's negative and one's positive. Or one's plus or minus.
The answer to the first part of your answer is correct. The second part of your answer is incorrect. You can cancel, but not because it's positive and negative. All right. Remember what we said. Remember,
That makes 1.
we're going to do what to this? We're going to turn it into how many fractions?
2.
2 fractions. So we're going to take this denominator and we're going to give it to each part of the numerator. So this is going to become 2 over 2 plus or 2y square root of 3 over 2. Now, the reason that, now, Jillian is correct that we can cancel stuff out. But my feeling is that if you don't first separate the fractions, you're not going to cancel it out completely. So this is a way that hopefully ensures that you cancel it out properly. Because here's what I'm concerned that you're going to do if you don't separate it into two fractions. You're going to say, oh look, 2 is divisible by 2, so my answer is 1 plus or minus 2y square root of 3. That's what I think that you're going to do, or most of you. But that's not right. Because what you're going to do, notice what we can do if we break it into two fractions. Now, what's 2 divided by 2? Well, 2 divided by 2 is still 1, so I do get 1 plus or minus. But look what I can also do here. I have another 2 over 2 that I can cancel out, leaving me with just I times the square root of 3. Okay, so does everybody look at the difference? Here I have 1 plus or minus 2i square root of 3. Here I have 1 plus or minus just I square root of 3. This one is wrong. This one is right.
Wait, why did you put 1 plus I?
Because 2 divided by 2 is 1. You can't, it's not like canceling out, where we cancel out the x's and we just say, okay,
You
if,
cancel out the 2 over 2?
well, you're not, no, you're simplifying it. You're actually dividing it. 2 divided by 2 is 1.
So then wouldn't it be 2 plus I? Because you canceled out 2 over 2.
No, you're not, don't think of it as canceling. Think of it as simplifying. It's 2 divided by 2.
Yeah, I know, that's 1. And then you
Right.
canceled out 2 over 2 and then did 2 over 2 again. So
Right,
that would be
because
two
I-
ones.
Right.
So that would be 2.
No, because this is not 1 plus 1. This is not 2 plus, I should say, this is not 2 plus 2.
No, I'm talking at the end, right there, when you divided them up, and it's 2 over 2.
Right, but this, it's not this plus this. It's this plus this whole thing mushed together. So it's not 1 plus 1. It's 1 plus this, I square root of 3.
You canceled out 2 over 2 in the second one.
Hey, stop using the term canceling because I think it's confusing you. You're simplifying it. You're simply dividing 2 divided by 2, which
Yeah,
is
that's
1.
fine. And then
Right.
you did the same thing with that.
Right.
Which is 1.
Right.
So that's 2 ones. So that would be 2.
No. Because you're not adding them together. Because they're not, there's the second one, the one that you want to add to the first one, it's stuck to the I times the square root of 3. You can't pull it apart from the I square root of 3 and then add it to 1. What? Right. Think of it as an electric fence. It's like, Laura.
No, I get it.
Okay. Now, this is why we circle that x equals 0 right at the beginning of the problem. Because now you've done all this other work, and you get down to this as your other two answers. If you haven't previously circled that x equals 0, you're going to forget that you ever factored it out. And you're only going to, if you get these two, but you also don't get 0, you're only going to get 2/3 credit for the problem because you missed the solution. That is why, again, that is why it's important to indicate your first solution as soon as you find it. Find it, indicate it, and then forget about it. Okay, does anybody have any other questions about this? Yes, question?
So is X always gonna
X is always going to be 0 if you factor it out of the polynomial. Like if I started with this, and I didn't have this part, then no, 0 would not be a solution. Then my answer would just be these two things.
What's the final problem?
What's the final answer? I'm just, is that what you're asking? Yes, what's the final answer? The final answer, there's 3 solutions. 1 plus I square root of 3, 1 minus I square root of 3, and 0. Those are the 3 answers.
We have all those problems to do now.
No, you have all those problems that are due Wednesday. Plenty of time.
Oh, we have homework.
Okay. Okay, I'm now going to show you yet another way to solve a polynomial equation. This way is tricky. The quadratic formula is time consuming, but it's not tricky. This is tricky.
Okay. Thank you.
All right, but basically what you're going to be doing here is you're going to be fooling the problem. All right?
What is that first word? Apply? What is that word?
Solving.
Okay.
So we're still under solving polynomial equations by factoring, but this is a third way to do it. How you go about solving it depends on how the problem presents itself. So on Wednesday, the problem presented itself that we were able to factor it by multiplying A times C and getting the factors of B. So that was a more straightforward factoring. Second scenario is we can't factor it that way, so we have to use the quadratic formula. Now, look here. What's the problem? I want to factor this, but what's the problem?
There's nothing to factor out.
There's nothing to factor out. I have no greatest common factors. So I don't have 1x squared. I have 1x to the 4th. So all those ways that we learned, can't use them. Quadratic formula?
No.
Can't use it. Nuh-uh. Well, they prove it. Not done, did it? One big proof down this jump, sure. Use quadratic formula. Not
What
done,
is
did
it? Are you speaking English?
Yes. My George
No, it's
H.W. Bush impersonation. My interpretation of Dana Carvey's impersonation of
Oh,
George
yeah.
H.W.
This was Spencer. I thought you were a kid at parties.
I'm bad at parties. I'm antisocial.
Me too.
Okay, so we have to come up with another way to do this. And the way that we're going to do it is we're going to fool the problem into thinking we have a quadratic equation.
Ooh.
Right?
Right.
So what we do is we're going to substitute, we're going to take the letter A, and we're going to substitute that letter A in wherever we see the value x squared. So let's take a look. Here's my problem. Let's take a look at the easy substitution. The easy substitution is, well, here's x squared. Very straight ahead. So where I see this x squared, I'm going to put A. Okay? This is the one that's tricky. Because I don't see x squared. I see x to the 4th. But if you think about it, can't I rewrite x to the 4th as x squared times x squared? So now if I'm substituting, instead of x squared, I put A times A. And that's why it says A squared here. Because what I've done is I've changed the form of x to the 4th power. I changed it into x squared times x squared. Still x to the 4th power. Multiply these two together, you get x forth. And then, because I'm letting my a value substitute in for x squared, I can say, okay, x squared, I'm turning you into a. And I can say, hey, other x squared, I'm also turning you into a. So what do I get? I get a squared minus 3a minus 4. Now I have a quadratic. And even better than that, I have a quadratic whose leading term is 1. So now I can go to the easiest way to factor that I know, which is find the factors of c that add up to b. So what are the factors of negative 4 that add up to negative 3? Well, what are the factors of 4? There's 1 and 4, there's 2 and 2.
1 and 4.
Has to be 1 and 4. So one's going to be positive, one's going to be negative. My answer needs to add up to negative 3. So my two factors are going to be
1 and negative 4.
1 and negative 4. So I make that a minus 4 and a plus 1. So you see how we tricked the problem? We tricked the problem into thinking it's a quadratic equation. So that we can factor it in a way that we know how to.
I think the A thing
Right. Once we do that, once we have factored it, now we don't need that a anymore. So now we're going to go back and we're going to put our x squared back in. So we're going to unsubstitute the a. We're going to put the x squared back in. And now we're going to factor each binomial. Now, hopefully by now you recognize this as something. X squared minus 4. X squared minus 4 is what? What special kind of quadratic is x squared minus 4? What is it? What is 4?
A perfect square.
4 is a perfect square. What is x squared? X squared is a perfect square. So I have the difference of two perfect squares. How do I factor the difference of two perfect squares?
Oh, divide both, find the third of both of them.
And then do what with the factors?
And then you find the common factors. Or you do
Find the square root of each term. One factor is
that
plus,
one. Oh, one's minus.
and one is minus.
Yeah.
So I factor x squared minus 4. Difference of two perfect squares. You take the square root of the first term, take the square root of the second term, 1 plus, 1 minus. And once I do that, I now have two of my answers. Because remember, when we have factors, we know what the zeros are. If my factor is x plus 2, what's my zero? One of my answers is x is equal to negative 2. If my factor is x minus 2, then my answer is positive 2. So now I know two of my answers.
So one is
Be negative
negative
to the
and
first
one's
one?
positive.
Yeah, sorry. Let me make it clearer.
Oh, wait.
No, we still have x squared plus 1. Alright, now, x squared plus 1, on the one hand, we don't have the difference of two squares, we have the sum of two squares. Can't do plus and minus. It's not a trinomial, so we can't factor it in any known way that we have learned. On the other hand, how we solve it is actually pretty simple. All we're going to do is solve for x. So I take my x squared plus 1 and I set it equal to 0. I subtract 1 from both sides. I get that x squared is equal to negative 1. to solve a square, I do what? I take the square root. So I get that x is equal to plus or minus the square root of -1. Well, I know what the square root of -1 is. Square root of -1 is I. So I have plus I and I have minus I. So there are my other two answers, plus or minus I. My first two answers come from the other factors, x is plus or minus 2. My second comes from comes from this, it will be plus or minus I. And those are my answers. Okay, does anybody have any questions? Okay. Is there anybody who did not get one of these handouts yesterday? Anyone who was absent? Anybody else? Anybody got one? Alright, is there something on here? We're done with the lesson, but there is something on here I want to go over with you. And that's specifically when I'm dealing with perfect cubes. You'll notice number 6 on the handout says sum or difference of cubes. Just like we have perfect squares, numbers that when we take the square root we get whole numbers, we also have perfect cubes. Numbers that when we take the cube root of that number, we get perfect squares. So perfect cubes are 1, 8, 27, 64, and 125 are probably the ones that you are most likely to encounter. Anyway, what you have on your handout is a numerical example of the sum or difference of two cubes. But my experience tells me that if you don't understand how to do it, seeing the example on the page is pretty much useless. So, where you have sum or difference of two cubes on your handout, you should go ahead and copy this down. This is we'll call it the schematic. This is the template for how to find the sum or difference of two perfect cubes. So write it down generally, and then I'll show you how to do one with specific numbers. So write the general form underneath what we have, and then leave room to do an actual problem. And I think what you'll see is, once you see how the process works, you'll see that it's actually pretty easy. First thing you want to do is you want to label your terms. You got two terms. You got the x and you got the 1. So the first term we call A, second term we call B. Once you do that, now you look at it and say, okay, it's the difference of two cubes, so I'm going to follow this template, the second one. So we're going to come up with two factors, a binomial and a trinomial. So my first factor, my binomial factor, is simply A minus B. Well, what's A? Now, x. Well, A is x and B is 1. So my first factor is x minus 1, A minus B. My second factor, which is a trinomial, is I take the A value and I square it. What is x squared? X squared is x squared. Notice, if the sign in my first term is a minus, the sign in my second term is a plus. It's the opposite. Good. The middle term, I simply multiply the A and the B together. What is 1 times x? 1x. So it's just plain old x. And then for my last term, you notice in both cases, the second sign is plus. So no matter what else happens, this is plus. The last term is your b value squared. What's your b value? 1. What is 1 squared? 1. There's your factoring of a perfect cube.
That's all you have to do.
That's all you have to do for that. Yes, sir.
What were you multiplying that whole time?
whatever your A and B values are. That answer your question?
Kind of.
Can you restate your question then?
For example, x minus 1, you guys are multiplying that, right?
In the middle, only in the middle. The two ends, the
Oh,
left side is this
I
number,
see.
this value squared, the right side is this value squared, the middle is you multiply them together.